Hello, and welcome to the Tech Talk on topic Deep Dive on Migrating and Modernizing Middleware Applications. I'm Amit Bajaj, Partner Solution Architect with Migrations team here in AWS. Let's get started. So here is the agenda for 35 to 40 minutes of a long session. We will talk about what are the middleware applications and what are the underlying technologies behind the middleware products. Where and how can we migrate those middleware products to AWS? You will walk away with a deep understanding of different AWS services available to create middleware and application integration solutions in AWS. And you will also have a knowledge of all these services to use in your projects in this area. Towards the end of the session, we're going to have a Q&A session so you can use your chat window to send your questions. So what are the middleware applications? For many decades, software architectures are built with mainly two strategies: divide and conquer, loose coupling. And we have seen this architecture at many enterprises where applications are on their own infrastructure or distributed and communicating over some kind of message-based or event-based pipe. In last one decade, it has further been extended using service-oriented architecture. And these applications are further subdivided into the services, or so to say, microservices. That means further distribution. This is done to achieve the strategy called divide and conquer because it makes our development, deployment, and operations much easier due to the separation of concern. On loose coupling, the best way to achieve loose coupling is asynchronous messaging or eventing. So when we talk to the customers, they have a REST or SOAP APIs on their radar, but asynchronous messaging is also a very significant part of their applications. Almost all of the enterprises have some kind of asynchronous messaging in their IT landscape. So applications which help us to create the asynchronous communication bridge in a distributed architecture are called the middleware applications. There are many commercial products as well as open source products which help us to build these middleware capabilities. For example, IBM MQ, ActiveMQ, TIBCO, EMS, Apache Kafka, and RabbitMQ. According to one of our distinguished engineer in AWS, if your application is cloud native or a large scale or distributed and does not include a messaging component, that's probably a bug. And I believe he's right. So in my experience of working with Fortune 500 companies, I have not seen even a single organization without some kind of message or event oriented middleware piece. So the core of middleware application is messaging or event streaming. These are the basic units of data which flows through the distributed systems. Let's quickly jump into these two concepts before we jump into the migration paths available for these. First key difference is in the payload. In event streaming, these are the very small key value pair and that are sent across a stream. That value is typically just an atomic value. That does not mean it cannot have a large JSON object or a large XML, but typically it is very small atomic value, mostly 10 bytes to 100 bytes max. Whereas with the standard messaging, we typically do have those very large payloads. For example, those order payloads with 45 different attributes value. So we can actually see the animation, what is really happening there. We notice with the event streaming, we have unbounded continuous flow of data. In other words, these key value pairs are continually streamed out through this streaming topic or the queue. Whereas in the standard messaging, you see a bounded message is being sent by the sender or producer and received by the receiver and consumer. That's really inherent difference between these two. Another difference is with the event streaming, we can get a throughput of like 100 upward of 100,000 messages per second with a regular size messages. Whereas in messaging, with apples to apples match, where we know that event streaming platform always persists the message, standard messaging can achieve few thousand messages per second with the persistent messages and tens of thousands of messages per second with the non-persistent messages. That's another significant difference. So that throughput values makes decision easy when we should use event streaming or enterprise messaging. The other thing is the usage of data. So event streaming platform is really good for what I like to call as operational data. This data is metrics data, auditing, logging, uptime metrics, and the heartbeat data, whereas messaging data is more transactional in nature. These are the user requests, in other words, creation of an order or validation of a trade or a trade order. So that's not to say that you can't use Kafka for transactional data, but with the unbounded continuous flow of data, payload with 55 attributes is difficult to do or manage, whereas in messaging, it is fairly standard. So why we need event streaming? So event streaming has emerged at the right time with the right technology. Event streaming is not just a messaging, but much more. Let's look at how event streaming is supporting today's business needs. 87% of the companies are looking for ways to be more customer centric. That's a lovely phrase, but what does it really mean? To me, as a user, when I look at the new product or a new service, I don't care how many cool features it has. All I care is it works for me. So that has a whether that has a usable experience and enough features to serve my needs. So companies are trying to be more customer centric than adding those flashy features. For example, airline app. If I have a flight and I reach airport to find out that it is cancelled, that's not a good experience. Instead, if airline can send me a notification that your flight is cancelled for so and so reason or delayed for so and so reason, and then it gives me options to book the next flight right there in the app, and then update my landing time based on my selection so that my taxi app gets updated automatically. Similarly, that app can also send me push notification for everything, whether it is good or bad, delayed baggages, weather alert or technical snag, etc. This whole event experience is centered around the customer, so customer feels better. And that's why to support those customer centric approach, middleware applications are going through a transformation of being event centric instead of a data centric. So data at rest is being modernized to data in flight. First priority is no longer preserving data, but it is rather responding to the events. And the data store is no longer a source of truth. Actually, it is the event store which is becoming a source of truth. So that converts your IT as an enterprise information repository into a IT as a digital business nervous system. And we need this approach because word has changed. The messaging systems which have been serving us for last 2 decades cannot scale to help in such use cases. With advent of IoT, mobile, machine learning, and microservices, lightweight event data has become a new de facto standard for messaging. Let's talk about migrations. So there are many key considerations when customers plan to migrate an application to cloud. Some of them are listed right here. Business goals. What are the business goal of an enterprise to migrate to AWS? It could be cost reduction, gaining agility, reducing operational overheads, or moving out of a data center. And application capacity also has a impact. Whether what are the number of users and what is the amount of traffic a particular application is serving. Understand what is the current requirement versus what is in the future, because that will also drive which migration strategy needs to be followed to migrate this application. Cost of migration. Migration cost involves resources required to take on a migration task for a specific application. Depending on the migration cost or a budget, choose the appropriate migration strategy for application. You might have already seen like 7 art strategies for a migration, and we have a white paper as well on this. Let's focus on 3 migration strategies out of those 7: rehost, replatform, and refactor. So based on the business goals and the migration cost, pick a strategy which makes most sense for an application. And we have seen customer takes incremental approach as well. They rehost to AWS first and then start optimizing it by adopting replatform and refactor approach later. As per this chart, moving up from rehost to replatform and refactor, effort and time to migrate increase as well. This is where business goals and the migration cost helps to determine the right strategy. Rehost is lift and shift approach. Main drivers are when customers don't want to disrupt the existing application code and they want a risk-free approach. And when they want to gain the cost reduction in a minimum possible time, or they have a deadline to move out of the data center. That's where customers choose rehost. In this case, customer still has to manage the application, such as maintenance, application lifecycle, patching, deployment, and operations. An example here is moving off your any database to which is hosted on a virtual machine on premises and hosted on a EC2. And replatform is about lift, tinker, and shift. This is when customers want to take advantage of the cloud native capabilities without changing much of the application code. Customer still has to manage its application code and scalability needs, but all of the undifferentiated heavy lifting, such as maintenance, management, patching, is not required. For example, replatforming on-premises database to AWS RDS. That saves a lot of cost as well as operational overhead to the customer. Refactor. This is a bit radical approach and it requires cost, effort, and time to migrate. In this strategy, customer has to change the application code to take advantage of the cloud native services. As a result, customer does not have to manage anything um, except the application logic. This is typically driven by the motivation drivers, such as strong business needs to add a feature, performance, lower cost, add scalability, add functionalities that would otherwise be very difficult to achieve in existing application code. And the example is breaking up a monolith to a microservices architecture in AWS. So these are the services in AWS to which middleware applications and products map to. Top row is about fully managed services, so to say serverless stack, which can be used to build middleware applications. Bottom row is about the managed platform, which is a managed version of open source product. So as a customer, you don't have to worry about underlying infrastructure, operations, or maintenance of the product, but you still have to take care of the scaling needs, network config, and security config for the managed platforms. Amazon MQ is a managed version of open source product called ActiveMQ. Amazon MSK is a managed version of open source product called Apache Kafka. These are our AWS services our customer use to build messaging and streaming solutions on AWS. Let's run through a decision-making approach on a different products customer has and what should be the migration strategy for those products. So the first thing is it an IoT use case we are trying to build or any IoT applications where many things and devices need to communicate with the cloud? If that is the case, start with Amazon IoT Message Broker and consider its benefits and limitations, like support for MQTT, HTTPS, MQTT over WebSockets, X509 certificate-based authentication, and the native integration into many of the other AWS services. It provides all of these out of the box. If not, next question would be whether it's an existing application we want to migrate to the cloud or whether it's a new greenfield application we are building. And let's assume if it's an existing application. There may be a constraint to existing services and then try to figure out what migration strategy we want to go based on the other factors such as cost or time to transform, which means figuring out whether we want to go for replatforming of this existing application or a replatforming or refactoring. If it's a replatformer of existing solution, which messaging or streaming solution do we use today? That will decide what should be the best AWS service for our solution. So if we're using Apache ActiveMQ today at on-premises, Amazon MQ becomes a de facto choice. Make sure to assess the advantages and limitations of Amazon MQ. If we are using Apache Kafka today, then Amazon MSK is an obvious choice. If customer is using Redis for their publish and subscribe functionality to do the messaging, then Amazon Elastic Cache on Redis is an obvious replatforming choice. If the customer is using IBM MQ or TIBCO EMS or any other commercial brokers, look at the features of Amazon MQ. Actually, Amazon MQ supports almost all of the protocols like JMS, AMQP, OpenWire, and it has almost all of the features which any other commercial broker has. And so Amazon MQ becomes a replatforming choice there. If it is really some other product, then rehosting becomes the choice. Hosting it on EC2 automatically provides all of the cloud benefits customer gets. Now, if migration strategy is refactoring, or if it is about the new application customer is trying to create, in those scenarios, the decision making is actually same. So the next decision making question would be whether our solution need a event streaming based middleware or a message oriented middleware. If it is a stream processing use case, then assess the capabilities required for this solution. Like, whether it needs a retention period of more than 7 days or whether it needs a log compaction on the event store. In those cases, use Amazon MSK. But if there is no such requirement, then the recommendation is to use Amazon Kinesis Data Stream because it is fully managed by AWS and turns out to be cost-effective service. But as we know, migration cost might go higher because of the producers and consumers might need to change to follow the API-based communication with the Kinesis. Now, if it is a message-based solution, then based on the type of the channel, AWS recommend different services. If it is a point-to-point channel, and if requirement is a strict ordering, then use SQS FIFO. Else, use a standard SQS. Performance on the standard SQS is much more than the FIFO-based SQS. As we all know, any FIFO or strict ordering-based communication, there has to be a single-threaded process at some point, which cause the performance degradation on those ordering queues. And if the channel is publish subscribe and there is no strict ordering requirement, go with Amazon SNS. It is widely accepted solution, at most of our customers. If ordering is important with the publish subscribe scenario, then recommendation is to use alternatives such as the use Amazon Kinesis or use Amazon SQS FIFO with a custom fan out logic to multiple SQS FIFO queues. So that's another solution for that. If it's a new application or a refactoring of existing application and the SaaS integration is a key requirement, use Amazon Event Bridge, which is an event bus. Amazon Event Bridge is a serverless service launched in AWS Summit in 2019. It has all the features which you saw in CloudWatch events. In addition, it comes with out-of-the-box SaaS connectors for SaaS providers, for example, Zendesk, ServiceNow, Auth0, etc. There is a full view of decision-making tree when it comes to middleware application migration or modernization. And as you know, every week we are adding new features and services in this segment. AWS AppFlow is one of the other service which we did not discuss, but it also addressed the middleware use cases. Let's look at some of the migration use cases for all three: rehost, replatform, and refactor. So we're going to discuss how on-premises MQ product can be migrated gradually using rehost, replatform, and then refactor. We will also go through a replatform use case for on-premises Kafka. And we will also go through a hybrid use case for a migration project. So most of the large enterprises that we come across have on-premises messaging system. They may be using expensive commercial brokers from IBM and TIBCO or any open source solution. In many cases, an organization may have a mix of broker solutions. So let's try to map our migration strategy with the message brokers and see how it looks like. Let's try to map our migration strategy here. So in a rehost, customer could choose to migrate their commercial messaging application as is to EC2 and then gain the cost benefits. through infrastructure as a service. But licensing, provisioning, support models remain unchanged. So you are still owning those activities for your message broker on EC2. For a re-platform, it delivers the TCO efficiencies by leveraging a managed service, cloud OpEx models, durability, availability, and security. And it also you can reuse existing applications without modification. And it also ensure long-term flexibility, leveraging all the industry standards, as well as customer don't have to worry about expensive licenses. Refactor. Here, customers can refactor their applications to AWS, maximizing both cost and modernization benefits. But if they want to use them with the existing system built on industry standards like a JMS, they have to rewrite a lot of applications. So there, the migration cost will be high, but you are going to get a fully managed modern architecture, and which can scale infinitely. In typical case where customers are running IBM MQ on premises and happy with it, and company has a deadlines to move out of the data centers, in those situations, rehost migration to AWS might seem like a good option. And AWS provides free service called Cloud Endure, which can lift and shift messaging applications with a zero downtime. Another way of migrating is using AWS Quickstart. There are quick starts available for commercial brokers such as IBM MQ and TIBCO EMS and others. Just deploy the reference architecture using those quick starts, copy the configuration, and then gradually change the endpoints for consumers to AWS hosted broker, and then gradually change the producer endpoints to the AWS hosted broker. But keep in mind, only the underlying infrastructure is changed. Rest all of the broker maintenance, management, and admin tasks needs to be performed by the operations team. Here is the reference architecture for IBM MQ Quickstart. It follows well-architected principles to deploy secure, scalable, and reliable IBM MQ reference architecture. Next one is replatform. So typical enterprises migrating to AWS, they want to take the benefits of AWS capabilities such as analytics, machine learning, IoT, etc. Let's assume IT team has a mandate to migrate to the managed services wherever possible so that they can offload their operational overhead to AWS. So to say, offload your undifferentiated heavy lifting to AWS. In those situations, Replatform makes absolute sense. They can move their unmodified applications to the cloud and replace their messaging system with the Amazon MQ. If apps are using standard APIs like JMS, they can keep using it. So you don't have to worry about availability, scalability, and storage of the broker, and you don't have to change the way those producers and consumers communicates. Let's take a closer look at a case study for Example Corporation for the replatforming. And we're gonna look at what is the existing situation. So currently it has an on-premises IBM MQ, and that is supporting 4 applications. And JMS 1.1 APIs are used to send and receive messages. There are 20 queues, and 2 of them require strict ordering. Messages cannot be lost, so zero loss on the messages. Cannot have a downtime during the migrations. Total throughput those applications need is 1200 messages per second. There is no encryption on premises, but customer wants encryption when it is in the cloud. And this solution is a HIPAA compliance right now, and it is using JMS-based tools for monitoring. Now, if we map those requirements to the Amazon MQ, it has a JMS 1.1 compatibility. It provides FIFO queues, which follows strict ordering. It is Amazon MQ is also having a persistent multi-AZ storage, 11 nines, providing 11 nines of durability. And then you can also provision Amazon MQ in active standby mode, which will provide 99.9% of uptime. And Amazon MQ is also provides you two configurations, EBS-based MQs and EFS-based MQ. So EBS-based MQ will provide you higher performance than the EFS-based MQ. And then it also has a mandatory TLS on all connections, and the storage can be encrypted using customer provided keys. And this service is also HIPAA compliant service. For monitoring, Amazon MQ use CloudWatch. So if we see that we meet all the requirements for replatforming this broker from IBM MQ to Amazon MQ, then the next step is do the proof of concept, where ensure that the application work with the new message broker. First, copy those on-premises applications, or install those on-premises application in AWS. Create an Amazon MQ broker. Create with M5 to X large to support 1200 messages per second, and also have active standby mode for high availability. Modify the app configurations to to use the JMS endpoint provided by Amazon MQ instead of IBM MQ. And then just run the application and see whether the messages are being exchanged within the applications. And then use the CloudWatch to monitor the message flow through the queues. And then, of course, test the performance. So this is the way you can implement that proof of concept and see whether Amazon MQ is going to support all your needs which you have from the on-premises applications. And there is an incremental approach also when it comes to really phased-wise migration from IBM MQ to Amazon MQ. And we're going to discuss that in a couple of slides here. So these are some of the resources on how to migrate from IBM MQ to Amazon MQ, how to migrate from Rabbit MQ to Amazon MQ, and there is a migration guide available that how to migrate from commercial MQ to Amazon MQ, what all the things needs to be considered, what are the feature parity, and all those good things on migrations. Thirdly, on a refactor use case, it is mostly about you have to rewrite your applications to change the protocols from JMS or any other AMQP or any other protocol those applications are using currently to a API-based messaging with Amazon SQS and SNS services. And while changing those applications, consider using Lambdas, Fargate, and API Gateway also. And once you have those applications refactored, it is a lot less operational overhead now because because SQS and SNS on all these serverless services can scale nearly infinitely, and you don't have to do any maintenance or management of these services. But there is an upfront investment to refactor those application code. Next is about the replatform use case for Kafka. So on the left, you have an on-premises Apache Kafka, which you want to replatform to Amazon MSK, and you want to use and then there are many different replicators which helps you. Mirror Maker is an open source replicator which helps to do the replatforming of this scenario. But there are other commercial replicators also. For example, Confluent, Uber, and LinkedIn replicator. For now, those are not supported with MSK. So let's see how Mirror Maker helps to migrate on-premises Kafka to Amazon MSK. So as shown in this diagram, on the left side is the source Kafka cluster, and on the right is target MSK cluster. So each Kafka install comes with a zookeeper, which is a metadata layer for the Kafka cluster, stores configuration data for the producers, consumer, and Kafka cluster. Mirror Maker tool bundles the consumer, which gets messages from the source Kafka cluster and producer to send messages to the Amazon MSK. You can have a multiple consumers, but there is only one producer. Data is read from the topic from the source cluster and write into the same name topic in the destination cluster. If you have an auto create topic property set to true, then the Mirror Maker even create the topic in the destination cluster. So Mirror Maker version 2 can replicate the topic configurations as well from the source cluster to the destination. To increase the throughput and the fault tolerance, run many such Mirror Maker instances across multiple machines. One important thing to keep in mind is the source and the destination cluster are totally independent and can be very different in terms of topics, producers, or consumers, in addition to the offsets. But the partition key is same, so the order is preserved on a per key basis. As a best practice, number of consumers should be equal to the number of partitions available in the source cluster. And as a best practice again, run the mirror maker in the destination cluster. In case of network interruption, messages are still available in the source cluster. But if mirror maker is installed on the source side, then based on the producer settings, there is a chance that events could be lost. So, and you can also whitelist or a blacklist topics on the mirror maker configurations. So let's look at the steps to migrate existing Kafka cluster to MSK. Create a MSK destination cluster, then start the mirror maker from your EC2 instances within the same Amazon VPC as the destination cluster. Inspect the mirror maker lag. And if you are migrating, once the mirror maker has caught up, redirect your producers and consumers to the new cluster using the MSK cluster bootstrap broker value. And that's it. Then shut down the mirror maker and your producers and consumers are migrated. Next is we're going to discuss about the hybrid use case. This is if you are in a process, if a customer is in a process of migrating to AWS and it's like, 2 years or 3 years of a migration project, customer concern is that all the applications which communicates through this middleware application does not get migrated all at once. It's gradual migration. So the customer want to make sure, middleware communication stays intact, even if some of the applications are in AWS and others are still in on-premises. For example, billing or inventory applications is still on-premises, and the CRM and HRMS has already moved to AWS. So we need some kind of a bridge between these two messaging systems because Amazon MQ and IBM MQ cannot communicate natively. So here we see, IBM MQ on left side is hosted on on-premises and having a producer and consumer applications connected to it. Now, on the right side, what we want to achieve is Amazon MQ with all those migrated producers and consumers. But how can we incrementally migrate to AWS while replatforming IBM MQ with Amazon MQ and incrementally migrate producers and consumers without impacting the running business? So at the beginning of such migration, your middleware solution as well as your internal connected applications are running on premises, as you see here on the left. And then in your VPC in AWS, you start with creating a managed AWS Amazon MQ broker, which you will use later to connect your applications in AWS to it, so that they can use a message broker located close to them with a low latency. Afterwards, you create a JMS bridge, which you see in the middle, which simply implements the proxy pattern. This proxy is responsible for listening on a defined queues or topics for the messages and forward these messages to the other broker. It is also important to mention that we are leveraging the auto scaling capabilities from AWS to provide high availability and resiliency. And we're going to look at on this high availability and resiliency in a minute here. So, and to connect your data center to AWS, you can use a plain connection via the internet, a secure VPN connection, or a dedicated connection via Amazon Direct Connect. I didn't plan to go into these details, but happy to answer questions if you have one. So in this example, we started to migrate a message producing application to AWS Cloud, which you can see on the top right. This means the JMS bridge has to listen for the message in the queue on the Amazon MQ and forward this message to the on-premises message broker where the message consumer application still resides. Similarly, when you start migrating the message consumer application to the cloud, you have to extend your JMS bridge to also listen for the messages in the queues at your on-premises message broker and forward these messages to Amazon MQ, where the migrated message consumer application now listens to. So you should use auto scaling to make sure that always a defined number of JMS bridge instances are running. This makes sure that your JMS bridge is highly available because these instances can run in different availability zones. To make this JMS bridge also resilient, it has to adapt to the changes in demand. This means it has to scale out and in automatically. You can do this by leveraging CloudWatch metrics and CloudWatch alarms. Amazon MQ already have the CloudWatch metrics available, which which can trigger the scale in and out for the JMS bridge. And IBM MQ also have open APIs to check the queue depth on the IBM MQ side, and those queue depths can be can be ingested into the custom CloudWatch metrics, which can help to scale in and out the JMS bridge. So with the increasing demand, JMS bridge will scale out if required and scale in again if the demand decreases. After you have migrated all the applications to AWS Cloud, you don't need the JMS bridge anymore, and you can shut it down as well as your on-premises message broker. So this is all of the applications migrated, and those are communicating using Amazon MQ. Let's look at it in a quick demo. So here is a GitHub link for this particular solution, and I'm going to use that same GitHub link, and we're gonna see it in a quick demo here. All right. So here is the GitHub link, and it has that solution out there available for our customers to use, and it follows the incremental approach as I discussed earlier in the slides. And you can use all of this resources to provision. So what I have done is I have already provisioned the resources. So if you see, this is my AWS account, and here I have provisioned Amazon MQ broker. I have provisioned the IBM MQ broker, which in a simulated on-premises environment. So right now, IBM MQ broker is hosted on as a ECS task on AWS Fargate. It is a simulated on-premises. And then I have this sample with environment variables. It is nothing but a JMS bridge solution, which is also hosted on a Fargate. So let's take a quick look on these. Here is the Amazon MQ broker, which is provisioned using that CloudFormation, and this is the web console endpoint. Let's open it up. So here you see two clusters. One is having IBM MQ and other one is supporting JMS Bridge. So we're gonna look at the IBM MQ cluster. And this is the public IP address for IBM MQ. So we're gonna use it just to access the console. It is going to prompt you user ID and password, and those user ID passwords are mentioned as part of the GitHub instructions. Okay, so here it is, the Apache ActiveMQ, which is the Amazon MQ. Amazon MQ is a managed version of ActiveMQ. So we're gonna go to manage, and it's a home page here, and then here is the IBM, and it has a couple of queues here, as you can see. What we're gonna do is we're gonna see how Amazon MQ is communicating with the IBM MQ using the JMS bridge. All right, let's see. Let's send a message from Amazon MQ to IBM MQ and see how JMS bridge route that message. Send. We'll say message from Amazon MQ demo. Tech Talk. And send it. Let's see on the MQ side and browse the messages. And here we see message from Amazon MQ demo Tech Talk we just received. Similarly, let's send the message from IBM MQ to Amazon MQ. Put message from IBM MQ demo Tech Talk. We're here, and go back, refresh your queues. So as you know, ActiveMQ or Amazon MQ creates the queues on the fly as soon as you send the message to that name. Let's click on it. There is one message. And here is that message from IBM MQ demo TT TikTok. So that's how these two systems, Amazon MQ and IBM MQ, are communicating. And you can start migrating, using this solution. You can start migrating your producers and consumers from using IBM MQ to Amazon MQ use. So that was a quick demo from my side. Let's go back to this deck. All right. So we saw, IBM MQ to Amazon MQ demo. Now, if the on-premises apps also use ActiveMQ, in that case, it is easy because Amazon MQ is also a managed version of ActiveMQ. So ActiveMQ on your on-premises can natively connect to the Amazon MQ because it is ActiveMQ within it. So in that case, you just need to add a configuration to one of the MQ system. And here is a little snippet of a network connector configurations placed put it on the on-premises ActiveMQ broker. So this is the network connector configurations, and here you see URI is actually pointing to the Amazon MQ broker hosted on AWS. That's how it connects. So with that, uh, let's get into the wrap up. So we discussed what are the middleware applications. We also discussed about what is the difference and similarities between enterprise messaging versus event streaming, how they are friends, enemies together. And then we also saw the migrations approaches or migration strategy, rehost, replatform, and refactor. And then we discussed what are the different AWS services which helps in a kind of a decision-making approach to migrate and modernize our middleware solutions. And in the end, we had three different migration use cases on rehost, replatform, and hybrid use case. With that, I thank you everyone for taking time out for this tech talk. Really appreciate your feedback. Thank you.